I'm here with Dr. Levon. Dr. Levon, why is that even some planets have bigger inner cores, but they have less energy within them?
Okay, of course, we know already throughout our solar system, like take the planet Mercury. Why is that planet Mercury, a large inner core according to the science, but has less energy? It's only 0.375. Why is that? A big inner core, now you may think over there, there's some scientists, if I'm correct, why is that large inner core gives less energy? Let me clarify this for you. The first of all, the only planet within our solar system was formed the same time like our sun. It was planet Mercury. How do I know this? Because planet Mercury doesn't have even one volcano on the surface of that planet. It didn't have a chance to relieve the energy from inside to create volcanoes. And why is that, that has less energy now? Let's see. Do you know the heat actually damaged the energy of the inner core? What it does, when the energy, the way it demagnetizes regular magnet, take the regular magnet, it's a fact. When you heat it up, the regular magnet, it get demagnetized. It the same way function like the big planets do. Imagine that, when this planet, it was just a newborn planet, and the sun had so much heat to it, it was actually getting baked. The crust of that planet, Mercury, it actually got baked completely. It didn't have a chance even to relieve itself because it got so thick, the crust, and got crystallized that it didn't allow the inner core to relieve itself and allow the planet to become a reality of what they're becoming throughout the billions of years. And let's take the second planet in a row, the planet Venus. Why is that? Even though planet Venus had so many volcanoes, but has the hottest temperature on the surface of that planet, and it imagine that the planet Venus, the day is a lot slower than the year of the planet Venus. Let's dig it deeper into that and see why exactly happened that. Now let's go back into planet Mercury. Imagine this, that tremendous heat. What actually did it damage? It damaged and it thickened. When it started to harden the inner core itself, like a rock, it lose the energy bond. When it lose the energy bond, it actually lose the energy out of it. Now the planet Mercury, it has so much gravitational force. How much energy got left within that inner core of that planet? Even though the planet inner core is large, but the energy concentration is very small. Now the end of the inner core is already hardened, just like the stone. Any stone exists within the surface of the earth. And you take the hammer or sledgehammer, slam the stone. What is going to do? It's going to break into pieces. And do you think that the stone will? Can you hook it up the electrical power? And do you think that will be good conductor for you? Obviously not. And think about that. The energy which one it no longer can pass through that, and it shrinks. And here is, I can give you now the good example why some planets, they release the gamma rays. What exactly the gamma rays? That's the high concentration of the energy which one exists within existing planets and the dying planets too. Now the gamma rays, you see, each time when the planet, the inner core start to harden, like the one happened with the planet Mercury, that existing energy, it just bursts and it goes out of that planet completely. It holds only what it can hold on to, and the rest of it, when it suddenly, when inner core start to harden, and the energy can hold on to it, and just energy bursts out of the inner core, and it travels and it dissipates in the universe, and that's what exactly each planet they produce the gamma rays. And this is the one. That's the one way of actually. There are many ways. The planet, the stars, and the planet, they release the gamma rays. Now let's go to the next planet, to the Venus. The planet Venus. Again, I said, it's the hottest planet in the universe. I'm sorry, I apologize. Within our solar system. Now let's see why is that. Even though it's farther away, it receives 30% less sun heat than the Earth does, but it's the hottest. Most of the scientists, they think actually just because of the carbon dioxide. The carbon dioxide is the one problem. But the problem is, now let's take the days. Like take the days. Why do you think, what happened to that planet? Actually, the crust, it got demagnetized completely. It has very little energy left to it. If one day of the Venus is longer than the year of the Venus, imagine it just get dragged over the inner core. And what do you think is going to create that? When it's dragging over the inner core, it will create heat. And the heat actually, which one is radiating from from inner core of this planet, because the friction, the inner core of the Venus and the crust, you see, when you check it out, the fact about the Venus, you can see the Venus has patches of hot spots, and you can see even the North Pole and the South Pole has hot spots in it. What exactly is that? Those are the spots which one is grinding toward the inner core. But when it's grinding, that creates the heat. And the heat, that's what it radiates into the atmosphere. Imagine that, You see, take a look, let's go back into the Mercury. The Mercury's daytime, it's hotter than the darkness. When you see the Mercury facing toward the sun, it's almost 400 degrees Celsius. But the opposite side, it's almost 180 degrees Celsius. Why is that? Because the Mercury doesn't have, any atmosphere. I mean, even though Venus has little atmosphere left, but it's weak. It cannot hold the heat to it. The only reason this planet Venus has so much heat, because the friction between inner core and outer crust, that friction, it constantly is creating a heat, and that's what is radiating back into the Venus's atmosphere. That's why the Venus is so hot. Not because it's surrounded with 95% of the atmosphere is a carbon dioxide. It's because the heat is radiate. Imagine if that one day it takes more than a year, and it's so long, the backside of that planet, sun never reaches there, and should have been colder, just like the planet Mercury itself.